So we continue with heat and energy, and now we are going to see the next part, and that is called as thermal expansion. Now we very well know that if this is a object over here and these are the molecules over here. Now if these molecules are given the heat, so when they are going to be heated, so if these are heated, it is going to happen that the random motion is going to keep on increasing, and on increasing this thing, what will happen? They will take some more. So initially अगर वो सब इतना हिल रहा है, तो अगर heat देने से वो थोड़े इतना हिलेंगे, तो क्या होगा? It will have more amount of space, so it will require more space, so it is going to extend on both sides, so the dimensions of the body is going to increase. So this increase in the size or increase in the length, breadth or height of a body when heat is imparted to it is called as thermal expansion. So why is the thermal expansion taking place? Is because on giving heat to the body will start vibrating more vigorously, and due to the vigorous movement over there, it will require some more space, and due to the more space required, it will expand. So that's why that almost all substances, solid, liquids and gases, expand on heating and contract on cooling. The same thing is going to happen when you do the ulta thing. That means if I am going to cool it, when I cool it, तो क्या होगा? जो उन लोगों का motion था वो धीरे 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 कम हो जाएगा, because the energy is being drawn out from it. When you draw out the heat energy from the body, the kinetic energy is going to reduce, and due to reducing the kinetic energy, the motion will come to slow down. Okay, the slow down of the motion of the vibration will decrease, the amplitude of vibration will decrease, and due to the decrease in the amplitude of vibration, there will be a decrease in the size of the body. So that's why it is seen that whenever a body is heated, it expands, and whenever it is cooled, it contracts. So the expansion of a substance on heating is called as thermal expansion of the substance. So expansion of the substance on heating is called as thermal expansion of the substance. A solid has a definite shape, but when a solid is heated, it expands in all directions. Okay, so when it is a solid over here, it has got definite shape, but when it is heated, it will expand not only lengthwise but also breadthwise and heightwise. So all the three dimensions, length, breadth and height, are going to increase when a solid is going to be heated. That is, the length, area and volume all increases on heating. The increase in the length is called as linear expansion. The increase in the area is called as superficial expansion, and the increase in the volume is called as a cubical expansion. So there are three kinds of expansion. One is linear expansion. The linear expansion is only for the length. If anything, now normally this will be done in case of wires or rods. Now you can see the wire or rod is being heated because the thickness and the height is very small. That's why whatever is significance, what you can see in the increase will be the length of the wire. The length of the wire is going to be showing much more increasing, or you can see, we can calculate the length to be increased that much, because otherwise the thickness and all will be so negligible that you can even measure that thing. So that's why when it is expanding only lengthwise, it is called as linear expansion. If it is going to be the superficial expansion, superficial expansion is the one in which the expansion is area wise, that is length into breadth. If the length and breadth, like for example, if it is a thin sheet of paper, or sorry not paper, thin sheet of a metal, तो metal sheet का रहेगा तो उसका length भी और breadth दोनों increase होगा, thickness इतना पता नहीं चलेगा. So that's why it is called as the superficial expansion, which is only area wise, that is length and the breadth. And the other one is the volumetric expansion, or you can call it as a cubical expansion. So cubical expansion is the one which is going to be in all direction, length, breadth and height. So when the length, breadth and height, that means the thickness, the width and everything, it is normally done in a solids. Okay, then solids के अंदर हम लोग जब heat करेंगे उसको, तो उसका length भी increase होगा, उसका width भी increase होगा, height भी increase होगा. So that will be called as a cubical expansion. So these are the three kinds of expansion which can take place in substances. That is linear expansion, superficial expansion and cubical expansion. The liquids and gases do not have definite shape, so they have only cubical or volume expansion. On heating, liquids expand more than the solids and the gases expand more than the liquids. So it is always seen that See, when I talk about the length, you don't have a length in case of a gas or a liquid. Area wise also, you do not have an area of a gas or a liquid. So whenever we talk about the gas or a liquid, you are talking only about the cubical expansion, because it has not, it will be taking the shape of the container. So container के हिसाब से जब हम लोग उसको heat करेंगे, तो it will be inside the container that is going to expand. So that's why on the liquid and gases do not have definite shape, so they are having a cubic expansion. On heating, liquids expand more than solids, and the gases expand more than the liquids. So of course, because the random motion, see, in case of liquids and in gases, there is very less amount of intermolecular force of attraction and more amount of space between the molecules, due to which when heat is given, they are going to go much more wider. Hence, the kinetic energy is going to immediately get increased in case of gases, slightly less in case of liquids. So that's why whenever heat is given, the volumetric expansion of liquids will be much more than the solids, and the gases which will much more than the liquids. So always, if you see, the cubic expansion will be greater in gases, then in liquids, and then in solids. But there is some exceptions over here. Some substances, such as water from 0 degrees Celsius to 4 degrees Celsius, silver iodide from 80 degrees Celsius to 141 degrees Celsius, and silica below minus 80 degrees Celsius, contract on heating and expand on cooling. So this is something different. So abnormal, this is something like an abnormal behavior of certain substances. So in this case, what we are going to study mainly is water. Water between 0 degrees Celsius to 4 degrees Celsius, it behaves abnormally. Okay, the other example they already given you is about silver iodide from 80 to 141, and silica from minus 80 and below. So these ones, it will be ulta. What do you mean by ulta? Okay, when you are heating it from 4 degrees, 0 degrees to 4 degrees, when I am heating from 0 to 4, instead of it expanding from 0 to 4, it is going to contract. Similarly, from 4 to 0, it should have contract, uske badle kya hoga? Expand. So, it is seen that water, when it is, suppose I got water at 20 degrees Celsius, usko maine cool karne ka chalu kiya, so till 4 degrees Celsius, it will keep on contracting. Okay, the size will keep on decreasing. So from 20 degrees Celsius to 4 degrees Celsius, it will keep on decreasing in the volume. But the moment it reaches 4 degrees and then you go down to 0 degrees, instead of it contracting, it starts expanding. And since when it forms into ice, it is having the volume more than that of water. So the volume of water, it will be less as compared to ice, or we can say that the density of the ice will be less than that of water, and that is the reason that ice floats on water. See, we are learning flotation that अगर density जिसका कम रहेगा वो उसके ऊपर float होगा. तो पानी का density अगर, see, if you see water, when it is going to cool down, it is going to contract, and when it contracts, then the volume decreases. If the volume decreases, its density is going to increase. But in case of water, what is happening? When it is from 4 degrees to 0 degrees Celsius, instead of contracting, it is expanding. And because of the expansion, what happens? The density of ice becomes less than that of water, and hence the ice is able to float on water. So this is nothing but the anomalous behavior of water. So the expansion of substances on cooling in a certain range of temperature is called anomalous expansion of substances. Here we shall study the anomalous expansion of water. So let's see how does the water behave anomalously. So what we have is anomalous expansion of water. Okay, so it is anomalous expansion of water. So that is between 0 degree Celsius to 4 degree Celsius. Okay, so water between 0 degree Celsius to 4 degree Celsius, it is going to behave abnormally. That means on heating it should expand, but no, it will not expand but contract. On cooling it should contract, but it will expand. So if we take some water at 0 degree Celsius and start heating it, we find that it contracts instead of expanding in temperature range from 0 degrees to 4 degrees. On heating it further above 4 degrees Celsius, it expands. Similarly, if water initially at a temperature above 4 degrees Celsius is cooled, it contracts till the temperature of water reaches 4 degrees Celsius. On further cooling it below 4 degrees Celsius to 0 degrees Celsius, it expands. This unusual expansion of water on cooling it in the temperature range 4 degrees Celsius to 0 degrees Celsius is called anomalous expansion of water. Thus, the expansion of water when it is cooled from 4 degrees Celsius to 0 degrees Celsius is known as anomalous expansion of water. So this is the definition of anomalous expansion of water, that the expansion of water when it is heated from 0 degrees Celsius to 4 degrees Celsius is called as anomalous expansion of water. Now this can be easily seen in case of the, we can say the graph. So if I draw a graph which is such that I have a graph over here which is going to be plotted against the volume to the temperature. So volume to temperature, if I start going through it. So at 0 degrees Celsius, you can see the volume, say if it is like यहाँ पे दिया है, they have started it as 0.999, then 1.000, 1.001, 1.002, okay, and so on. So if the value is such that this is somewhere between this one, this is 2 degrees, this is 4 degrees, this is 6 degrees and 8 degrees. So from here, that is between 1.01 or 1.015 के आसपास में, when the temperature is going to be increased, there is a fall in the volume. So the volume is going to fall till it becomes almost 1 at 4 degrees Celsius. At 4 degrees Celsius, it will become almost 1 centimeter cube. This is in centimeter cube, and this is degree Celsius. And then when you keep on heating again, you will find that it is going to keep on increasing and then it rises up. So you can see that this curve is such that from 0 to 4 the volume decreases, but after 4 the volume again increases. So this is the anomalous expansion or the variation of the volume of the water to in the range of 0 to 4. Now it's the same way we know that volume and density are related to each other. So same way, if I plot the density over here, so this is the density. The density over here, we see that again we are going to take the same value 0.996 and 0.997, 0.998, 0.999, 1.0, 1.001. Okay, so if this is the condition, you will find that initially the volume will be, the density will be at 0 degrees Celsius will be somewhere here, and then 2 degrees, 4 degrees, 6 degrees, 8 degrees. At 4 degrees it will go up till 4 degrees, it will go up till it reaches, sorry, this is 4 here, and then 6, and then it is going to drop down. So you can see that the density will be maximum. The density of water is maximum at 4 degrees Celsius. Okay, so it is seen that the density of water will be maximum at 4 degrees Celsius, and then again it decreases. So density below 4 is also less than 1. Above 4 is also less than 1. At 4 degrees Celsius, the density is maximum of water, and that is 1 gram per centimeter cube. So this is 1 gram per centimeter cube. So that's the density over here. So it is seen that the anomalous expansion is such that the volume is going to decrease up to 1 at 4 degrees Celsius, and then it is going to increase again, whereas the density is going to keep on increasing till 1, and then it is going to start decrease again at 4 degrees Celsius and after 4 degrees Celsius. So that's why we see that figure 6.1 shows the variation in volume of 1 gram of water with temperature in the range from 0 degrees to 10 degrees Celsius. The volume of water first decreases on heating it from 0 degrees to 4 degrees, and then increases on further heating from 4 degrees to 10 degrees. The volume of water is thus minimum at 4 degrees Celsius. For 1 gram of water, the volume of at 4 degrees Celsius is 1 centimeter cube. So this is the thing, that at 1 gram of water at 4 degrees Celsius will be 1 centimeter cube. So that's the equation, and that's why the density at that time is 1, because mass upon volume is 1 upon 1. Okay, so that's 1 gram of, that is mass. If it is 1 gram, then the volume will also be 1 centimeter cube. So that is the condition when the water is at 4 degrees Celsius. Figure 6.2 shows the variation in density of the water with temperature in range of 0 degrees Celsius to 10 degrees Celsius. When water is heated from 0 degrees Celsius, the density of water first increases from 0 degrees Celsius to 4 degrees Celsius, and then decreases from 4 degrees Celsius to 10 degrees Celsius. On the other hand, on cooling water from 10 degrees Celsius, the density of the water increases first up to 4 degrees Celsius, and then decreases when it is cooled further below 4 degrees Celsius to 0 degrees Celsius. The density of water is maximum at 4 degrees Celsius, which is equal to 1 gram per centimeter cube. So you can see over here, the density first increases from 0 to 4 and then decreases from 4 to 10. Whereas if I am cooling it from 10 to 4, the volume, the density is going to keep on increasing, and then from 4 to 0, it will keep on decreasing. So that's why the density of water will be maximum at 4 degrees Celsius, which is equal to 1 gram per centimeter cube. So that's the density of water at 4 degrees Celsius is 1 gram or 1000 kg per meter cube. Now to understand this thing more better, we will be having one experimental setup which is called as the Hope's apparatus. So the Hope's apparatus helps us to identify that how we are going to demonstrate कि किस तरह से anomalous expansion हो रहा है या नहीं हो रहा है. Okay, so that's the Hope's apparatus now. So let's see what exactly we are going to have over here. So in case of a Hope's apparatus, what we have is a container, and this container over here will be having another outside kind of a trough which is going to be there like this. So there will be a trough which is at a point which is just in between. So in between there will be this trough of the thing, wherein you can place certain kind of the substances. Now what we are going to place over here will be dry ice. Okay, it will be dry ice, and you are going to fill this container with water up to this point. So there will be water all over here, and there will be two thermometers, one inside here. This will be T1, and another thermometer. So this is dry ice, and there is another thermometer which is over here placed inside like this. So this is T2 and this is T1. So this is a thermometer and this is another thermometer, T1 and T2. So now let's see the reading of the thermometers. So T1 and T2. So initially let's consider that both of them, everything is just set up, and at that time the temperature over here is shown as 20 degrees here and 20 degrees here. Okay, so degree Celsius over here will be 20 and this is 20 degrees Celsius. So the whole thing is at 20 degrees Celsius, and then I put the dry ice inside. Now as soon as I put the dry ice inside, what is going to happen? The inside water, the water inside the this one is going to start. Okay, I just change this to T1 and this is T2 as per the textbook, so that you are not getting confused when you are reading this thing. So it is seen that initially, if everything is at 20 degrees Celsius, then first of all, as the cooling takes place, so what will happen? You know very well that when something gets cooled, it is going to contract, and because of the contraction it becomes heavier, and because of that the density being increased, it goes through, it is going to become the density is going to be not heavier, it becomes the density is going to increase, so it sinks. So cold water molecules which are going to be here, they are going to go down, the hot will come up, okay, and they are going to go rise upwards. Incorrect. So there will be a convection cycle which will be generated over here, so that the complete thing is going to reach 4 degrees Celsius without any problem. So both of them will require reach 4 degrees Celsius. So till the time when it is 4 degrees Celsius, like 20 से 12 पे गया, 13 पे 12 पे गया, 11 पे गया, 10 पे गया, 8 पे गया, everything will be quite simultaneous. There is not going to be much in. Of course, this is going to be first and this is going to be the next one, because the cold water will always go down and then it will go upward. So that's why the temperature inside this particular thing is going to be maintained over here at now, the moment this particular flask reaches 4 degrees Celsius, now what is happening? Now is the thing what is going to change. The moment the temperature inside becomes 4 degrees Celsius, then what is going to happen? We know that there is an anomalous expansion going to take place. So now, when the the molecule is going to be cooled, now because of anomalous expansion, what will happen? The molecule, instead of getting denser and sinking downwards, it will now become less denser and will start floating upwards. So that's why the cool molecule is just going to travel upwards. So the cool molecule travels upwards, all the cool molecules travel upwards now, due to which the T1 will reach a temperature of 3 degrees, but this will remain at 4 degrees because the hot water cannot go down. यहाँ का hot water ऊपर आ ही नहीं रहा है. There is no convection cycle. Convection cycle is taking place only within this much part. So क्या हो रहा है? यहाँ से 4 डिग्री वाला 3 डिग्री हुआ, वो ऊपर गया. 4 डिग्री वाला इधर आया, वो 2 डिग्री होके ऊपर गया. Then 2 डिग्री से ऐसा करते 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 क्या हुआ? This became 2 degrees. This is still at 4 degrees. Try to understand why this is at 4 degrees. This is at 4 degrees because this one is heavier. 4 degrees वाला जो है उसका डेंसिटी सबसे ज्यादा है. The density of water is maximum at 4 degrees. So there is nothing which can come upwards. The density being higher, it will sink, it will not float. And because it will sink and not float, that's why this is just not able to come upwards. The density is going to change only in this area where the temperature change is taking place between 4 to 0. So that's why this slowly becomes even 1 degree, this is still 4 degrees. This becomes 0 degrees, still this is 4 degrees Celsius. So later on, this is going to remain 0 and start freezing up. And now when it starts freezing up, still this will remain at 4 degrees Celsius only. So it will be seen that even if this would have freezed, this would remain at 4 degrees, and only after a long time, if there is freezing already done, and then the freezing can reach the other part because of the heat being absorbed by the ice. So when the heat is absorbed by the ice, it will start cooling later on. But till the time क्या होगा, यहाँ पे ये टेम्परेचर जो है और जब तक 0 पहुँचता नहीं है, this will remain at 4 degrees Celsius. So this is what is proving that anomalous expansion takes place. Because otherwise, what would happen? Otherwise, if this expansion would not take place, ये 4 के बाद में ये भी 3 होता, ये भी 2 होता, ये 1 होता, ये 0 होता, ऐसे ही करके it would have kept on decreasing. The temperature would have been constantly decreasing in both the thermometers because it would have been no anomalous behavior. But here, because of the anomalous behavior, it is seen that the temperature change is taking place only in the T1 part and no change in the T2 part, because the molecules present around in the T2 are heavier, or we can say more denser. That is why they are not able to come upwards and they are not taking part in the convection cycle. So let's see the explanation of this thing. In 1805, the scientist T.C. Hope devised a simple arrangement known as Hope's apparatus for demonstrating the anomalous expansion of water. Figure 6.3 shows the Hope's apparatus. The apparatus consists of a tall metallic cylinder provided with the two side openings P near the top and Q near the bottom, fitted with thermometers T1 and T2 respectively. The central part of the cylinder is surrounded by a cylindrical trough containing a freezing mixture of ice and salt. The cylinder is filled with a pure water at room temperature. The temperature recorded by both the thermometer is observed at at regular intervals of time. Observations. Initially, both the temperature T1 and T2 show same temperature, that is room temperature. Second, first the temperature recorded by the lower thermometer T2 starts decreasing. Finally, it becomes steady at 4 degrees Celsius, while the temperature recorded in the upper thermometer T1 remains almost unchanged during this time. So here it will happen that this T1 may remain as it is because of the convention cycle coming over here. So sorry, I made a mistake over here. This is not going to 4 बाद में आएगा, पर अगर यहाँ पे बीच में अगर ये 12 गया तो ये फिर भी 20 के आसपास में ही रहेगा, somewhere या 18 के आसपास में होगा, but it will not change drastically. But when this is 4, then this will also reach 4. Till that time, both are going to be that way. So while temperature recorded by the lower thermometer T2 remains constant at 4 degrees Celsius, the upper thermometer T1 shows a continuous fall in the temperature up to 0 degrees Celsius, and then it also becomes steady. So till 0 degrees Celsius, it is going to be such that ये 4 पे अटक जाएगा, नीचे वाला 4 पे अटक जाएगा, ये वाला जो है वो continuously decrease होते जाएगा. Thus finally the temperature recorded by the upper thermometer is 0 degrees, that of the lower thermometer is 4 degrees. They are given the variation in the temperature and the of T1 and T2 in the graphical form. So initially it is remaining at the room temperature and then falling suddenly after a certain time, whereas the T2 one जो है initially it is dropping down and it is going to 4 degrees and remaining constant at 4 degrees Celsius. Explanation: initially water in cylinder is at room temperature, say 12 degrees Celsius, which is indicated by the point A in the graph. As the freezing mixture cools water in the central portion of the cylinder, water contracts and its density increases. Consequently, the cooled water sinks to the bottom and the warm water from the bottom rises to take its place. Thus, by convection, water of the lower part cools, so the reading of the lower thermometer T2 falls rapidly. The reading of the upper thermometer T1 does not change because the temperature of the water in the upper part does not change, because there is no convection cycle formed over here. The convection cycle initially is only this way. It is only the here, because यहाँ से ऊपर आएगा cool होगा तो फिर से नीचे जाएगा. यहाँ से ऊपर hot water इधर आया, cool हुआ नीचे गया, या hot water ऊपर आया, cool हुआ नीचे हुआ. इसलिए ये part पे कोई convection cycle नहीं था till 4 degrees Celsius. Okay. The convection water of lower part cools, so the reading of the lower thermometer T2 falls rapidly. The reading of the upper thermometer does not change because the temperature of the water in the upper part does not change. This continuous still temperature of the entire water below the central position reaches 4 degrees Celsius. This is shown as a part AB in the graph. A and B. Now the reading of the lower thermometer T2 becomes steady. On further cooling below 4 degrees Celsius due to anomalous expansion, water on the central portion now expands. So its density decreases and hence it rises up. To take its place, water from top descends down, and by convection water above the central portion cools. So the reading of the upper thermometer now falls rapidly till 0 degrees Celsius. Not only 4 but 0 degrees. क्योंकि क्या है उसके बाद में यहाँ का जो 4 डिग्री का सेल्सियस का है, that does not have any change in its density. So the density is maximum at this point and that's why it is remaining downwards. When ऊपर का density कम होते जाएगा and the convection cycle is going to be formed. So the reading of the upper thermometer T1 now falls rapidly till 0 degrees Celsius and water near the top freezes to form ice at 0 degrees Celsius. Now the thermometer T1 shows a steady temperature of 0 degrees Celsius. This is shown by the part BC of the graph A and B. At this stage, the lower thermometer T2 shows the temperature 4 degrees Celsius at which water has the maximum density, while the upper thermometer T1 shows the temperature of water at ice at 0 degree Celsius. So that is how the anomalous expansion is being explained using the Hope's apparatus. Now, the anomalous expansion has got the various consequences over here. So we'll just go through the consequences which is going to take place in the anomalous expansion. So first is the anomalous expansion of water helps in the preserving the aquatic life during the very cold weather. Now this is very simple. So if we have got a lake, now this lake, so if this is a lake with a hillish area and this is a lake over here. Now till the time the temperature is going to be up to 4 degrees Celsius, there won't be any problem at all. The moment the outside temperature becomes like 1 degree or minus 1 degree or something, at that time what is going to happen? The upper layer over here is going to start freezing, but the lower layer is still going to remain at 4 degrees Celsius because of the anomalous expansion, because cooling जो भी होगा वो उसके particles नीचे जा ही नहीं पाएंगे. There is no convection cycle formed inside the water. Whatever is the cooling taking place only on the upper surface of the water, hence the upper surface becomes ice, but the lower surface still remains at 4 degrees Celsius. Hence the aquatic animals and plants are able to sustain even at very extreme climate outside, because the temperature inside the water is still 4 degrees Celsius. So in cold weather, when the atmospheric temperature starts falling well below 0 degrees, water at the surface of the pond or lake, initially at temperature above 4 degrees Celsius, begins to radiate heat to the atmosphere. So the temperature of the water starts falling up to 4 degrees Celsius. When temperature of water at the surface falls, water contracts, so its density increases and therefore it sinks in the bottom. This continues till temperature of the entire water reaches 4 degrees Celsius. So जब तक 4 degrees Celsius है, तब तक क्या होगा? It's going to cool, go down, hot air comes up, hot water comes up. Again, that cools, goes down, hot water comes up. So the convection cycle going to take place till 4 degrees Celsius. Now further cooling of the up layer below 4 degrees Celsius result in expansion of the water, and so its density decreases. As a result, water does not sink further, but it remains on the surface. When the temperature of atmosphere falls below 0 degrees Celsius, water on the surface rejects heat to the atmosphere and gradually freezes into ice. But water well below the ice layer remains at 4 degrees Celsius. The water layer just below the ice in contact with it will be at 0 degrees Celsius. Of course, जहाँ पे ये ice है कि इसका contact में है, वहाँ पे 0 degrees Celsius होगा. But because water is a bad conductor of heat, it is not allowing the heat from the inside to go outside. Figure 6.5 shows the formation of the ice on the surface of the pond or lake. Since ice is a poor conductor of heat, so ice now prevents the flow of heat from the water of the pond to the atmosphere. Thus temperature of the water in the contact with ice is at 0 degrees, while the temperature at the water layers below the ice gradually decreases to 4 degrees Celsius. As a result, fish and the other aquatic creatures remain alive in water of the pond or lake, though water on a surface has frozen into ice. Nature thus protects the aquatic life during the winter season. Also, there is another problem during the anomalous behavior, and that is the water pipelines. So water pipelines के अंदर जब भी पानी रहता है और वो अगर pipe के अंदर रहा तो it will expand and it will blast the pipe. So in winter nights, atmospheric temperature falling below 4 degrees Celsius, water in the pipeline expands and it exerts large pressure on the pipe, causing them to burst. Plants also die for the same reason, as the capillary burst when water expands below 4 degrees Celsius. To protect the plant, the field is filled with water. So that's why what they do is that the field जो रहेगा. Now what is required is that the capillaries of the plant should not contain water, but should not get freeze. So what they do is that they water the whole field. When they water the whole field, the water जब तक वो 0 डिग्री पे पहुंचेगा नहीं, तब तक roots में से पानी 0 डिग्री पे नहीं पहुंचेगा. That's why there will be the clever farmer, if he wants to avoid the frost of his plants, he will spread water, or he's going to fill the field with water, so that there is no rupturing of the capillaries of the plant. So the capillaries of the plants are safeguarded by rupturing by filling water into the field, so that there is no anomalous expansion inside the capillaries of the plant. So that was about the first part of the chapter. We continue with the next part, that is the fourth part of the chapter, in the next video.